This is the project we created called From Earth to Everyday, the story of silicate minerals. Today we're going to dive deeper into where silicate minerals come from, what they are, and how they shape our everyday lives. And we have 3 learning objectives to help with that.
Let's begin by reviewing what defines a mineral. A substance must meet 5 types of criteria to be considered a mineral. First, it has to be solid. This means it can't be a liquid or gas. For example, liquid water is not a mineral, but ice actually is because it's in a solid form. Second, it must have a definable chemical composition. Each mineral is made up of the same elements in the same proportions every time. Third, it has to be ordered, crystalline structure. In minerals, atoms are arranged in repeating organized pattern, allowing minerals to form crystals and giving them specific properties such as cleavage or hardness that are tailored to each individual one. Fourth, it should be mostly inorganic. This means it does not form from living things. For example, shells and wood would be considered organic minerals, whereas salt would be inorganic because it forms naturally. Fifth and finally, it has to be naturally occurring. If humans create a substance in a factory such as plastic, it cannot be classified as mineral, even if the chemical composition is the same. Synthetic diamonds, for example, aren't considered minerals, but natural diamonds are. Silicates are the most common group of minerals, making up about 90% of the Earth's crust. They all have the same silicon-oxygen tetrahedron, a small pyramid-shaped structure. These tetrahedra can link together in different ways, creating different silicate minerals with different properties.
Olivine is a green mineral that forms deep in the Earth's mantle and in mafic rocks such as basalt and peridotite. It has a glassy luster, olive green color, no cleavage, and conchoidal fracture, meaning olivine breaks along smooth, curved surfaces instead of flat planes. This shows it does not have cleavage and instead fractures in a shell-like pattern. Olivine is most commonly used in jewelry as the gemstone called peridot. It can also be found in foundries, places where metal is melted and used as sand for molds, and in the lining of furnaces because it can handle high heat. Most recently, though, researchers found that finely ground olivine is able to naturally react with carbon dioxide, allowing it to be helpful in removing CO2 from our atmosphere. Pyroxene is a dark green, black-colored mineral that has a glassy to dull luster at 2 cleavage directions at nearly 90 degrees, which makes this mineral stand out. Pyroxene is not commonly used in consumer products, but varieties of it, like the pyroxene spodumene, which is a lithium ore that is needed for batteries. Other types of pyroxenes are more commonly used for geological research to help scientists further understand volcanic and mantle processes. In fact, pyroxene minerals are able to tell geologists the temperature and pressure at which a rock was formed. Mica has many colors, ranging from colorless, white, black, brown, and even lilac. It is known for peeling into thin, flexible sheets and having a shiny, glittery luster, and has great heat resistance and thermal stability up to about 600 to 900 degrees Celsius, which is 1100 to 1650 degrees Fahrenheit. Mica is used for many things, such as a finishing additive to cosmetic products and paint pigments, filler in the automotive industry, general use in the cosmetic and care industry, including cosmetics such as foundation, eyeshadow, highlighter, and nail polish, and also used as a filler in cement. In ancient civilizations, mica was used as a substitute for glass panels, as sand was not readily available in some places to make glass. Quartz has a wide range of colors and comes in variants such as rose quartz and smoky quartz. It is a very hard and durable mineral that does not cleave easily. Quartz is most commonly used in jewelry, in construction such as cement, as a component in glass, in electronics, and in the form of quartz sand with ceramics. This mineral is able to generate an electric charge, allowing it to be used in time-telling devices like clocks and watches. Feldspar is the most abundant mineral group found within Earth's crust. It is usually colored pink, gray, white, or light red. The mineral has 2 cleavage planes that meet at 90 degrees with a glassy luster, making it easily recognizable. Feldspar is relevant to our daily lives due to its heavy demand as a material for glass and ceramics. It serves to increase the durability and melting temperature. The mineral can be found in sinks, dishes, tiles, and paint to improve strength and overall stability. Amphibole minerals typically appear brown, dark green, or black and form long crystals with a needle-like appearance. The minerals have a silky luster and two cleavage directions at 60 degrees and 120 degrees. The placements serve to help identify the difference between them and pyroxenes. Amphiboles are created within both metamorphic and igneous rocks and have a high heat tolerance and overall resistance. Although some amphibole varieties, such as asbestos, aren't used in construction due to health issues and statistics over the years, the mineral can still be found within car parts, cement, roofing, and insulation due to their temperature tolerance. They are also very useful for recording rock formation history.
Now that we know what our main silicate minerals are and how we use them, we're going to go look at what these minerals are found around the world and how their geography affects how often and how easily we're able to use them. Olivine crystallizes in the upper mantle of Earth and can be found in mafic and ultramafic rocks. Major deposits are large natural concentrations of rich minerals, can be economically mined and used for industrial purposes. Olivine is found in Hawaii, Iceland, Norway, and the San Carlos Reservation in Arizona, locations with volcanic activity or remnants. Pyroxenes are found predominantly in mafic volcanic regions like Hawaii, Iceland, and the Pacific Ring of Fire, as well as in basalt, gabbro, and periodite across the globe. Pyroxenes can be found in rock layers of South Africa, Russia, and many meteorites. Mica deposits are located in India, Brazil, Madagascar, and Canada. India is known for one of the largest productions of mica in history. Quartz is one of the most abundant minerals in the world. However, deposits of higher quality are located in Arkansas, Brazil, China, and India. Feldspar deposits can be found across the globe, with major contributors including Italy, China, Turkey, and the United States. Amphibole materials are very prevalent within indigenous regions, such as the Alps and Rocky Mountains, along with parts of Asia and Africa.
Across all the silicate minerals discussed in this video, one main idea has become clear. Silicate minerals are essential to both the Earth and our everyday lives. Each mineral has its own story, properties, and uses, yet together they show how connected we really are to the geology beneath us. Each mineral, forming in its own geological environment, allows us to use it in specific, purposeful ways. Quartz's hardness and electronic charge make it perfect for electronics and watches. Mica's heat resistance makes it useful in cars and cosmetics. Feldspar helps us create ceramics and glass. Olivine and pyroxene help scientists understand volcanic activity, and so much more. Our use of silicates allows us to connect the natural world to the things we rely on every day. Because they make up 90% of the Earth's crust, they are in our buildings, our technology, our jewelry, and almost everything we use. Studying these minerals allows us to further our understanding of how the Earth works and can remind us just how much we rely on our planet to help us progress and build our future.